Hello everyone. In this video, I will discuss solutions to 3 problems where we apply the U-substitution method to evaluate indefinite integrals. So the first example says this. We have an integral of the following function 4x cubed times the expression 3x to the fourth minus 1 raised to the fourth power. So the first step in a problem like this is to inspect the integrand and identify f and g. So the outer function and the inner function. In this case, f would be the power function that we're raising an expression in terms of x to the fourth degree. Okay, and then what about the inner function? That would be 3x to the fourth minus 1. And why is that? You will see that we have a constant multiple of the derivative of this expression present in the integrand. So let's go ahead and set up our substitution. That's going to be 3x to the fourth minus 1 equals to u. Okay, now let's differentiate each side of this equation. So we get 12x cubed dx on the left side, and on the right side we get 1 du. Okay, now if we take a look at the integrand, we do not have 12x cubed dx, we have 4x cubed dx. So we do have a constant multiple of the derivative, okay? But we need to convert everything that we have in our integrand in terms of u only. So what am I going to do here? I'm going to divide each side of this equation by 3. You'll see why. Now I have 4x cubed dx on the left, and on the right I have 1/3 du. Okay, why am I doing this? Because now I can substitute everything in terms of u. So let's go ahead and do that. Okay, so what is our new integral? It's going to be the integral, and let's see, what is 3x to the fourth minus 1 raised to the fourth power? That's just going to be u to the fourth. And what about the rest of it? Well, 4x cubed dx, this is just 1/3 du. So now we have an integral which is much simpler, and we can compute this integral, right? So how do we compute this? This becomes 1/3 times u. We raise the power by 1, so that's 5. And then also divide by that power. And then don't forget our constant. All right, so what is this? This becomes 1/15 u to the fifth plus c. And then the last step is to convert everything back to the original variable. So what is our answer here? It's going to be 1/15. U is 3x to the fourth minus 1. And then we raise that to the fifth power plus c. Okay, now we can always check if we've done this correctly. So let's go ahead and check. It's not a bad idea to do that as you're learning this method. So if I were to differentiate our result, okay, so what would I get? That's 1/15 times 5 times 3x to the fourth minus 1 raised to the fourth power, right? And then times the derivative of the inside, which is 12x cubed. The derivative of c is 0, okay? So we get that. So now let's simplify this. What do we get? Okay, so we get 60x cubed over 15. And then here we get 3x to the fourth minus 1 raised to the fourth power. And then 60 and 15, that gets reduced. So we get 4x cubed times 3x to the fourth minus 1 raised to the fourth power. And this checks out. That is exactly what we started with. Okay? Now, this last step is not necessary if you feel confident that you've done your computations correctly, but as you're learning this method, I don't think it's a bad idea to just go ahead and check, and it will also let you practice your differentiation skills. So what is our answer for this particular problem? That would be this expression right here, 1 over 15 times 3x to the fourth minus 1 raised to the fifth power plus c. Okay? All right, so here we had a power function, and it was a positive integer. Does it need to be positive? No. So let's take a look at the next problem. And here we have also a power function, except now we have a negative power. That's all right. Okay, so I'm inspecting my integrand and notice that I have 5x squared plus 1 raised to the fourth power in the denominator, or you can think about it as raised to the negative fourth degree. And the derivative of this expression right here is 10x. Okay, we don't necessarily have 10x in the integrand, but that's okay. We do have a constant multiple of it, so that's going to be our U-substitution. So let's write out our substitution. 5x squared plus 1, that's U. Okay, let's differentiate each side. So we get 10x dx on the left, 1 du on the right. Now I look back into my integrand. Okay, I have negative 5x dx. So what does that mean? That means I need to divide each side by negative 2, because my goal is to come up with this puzzle, right? All these puzzle pieces, put it all together so that I can write my original integral in terms of U variable only. Okay, so what do I get on the left side? I get negative 5x dx. That's exactly what I want to have in terms of U. So what is that equal to? That's equal to negative 1/2 du. Okay, so now that we have all pieces, we can rewrite our integral in terms of U only. So what is it? Okay, so the integral becomes, let's see, negative 5x dx. That's just negative 1/2 du. Okay, I'm making room over here. You'll see why. What about 5x squared plus 1 raised to the negative fourth power? Well, that's just U to the negative 4. Okay, so that's what we have here. And notice that this new integral is much simpler. It is not so complicated. We know exactly how to evaluate that. So what do we do here? Okay, so this becomes negative 1/2. We can pull the constant out. U to what power? Negative 4 plus 1. So that's negative 3. That means we also need to divide by negative 3. And then don't forget C. Okay, so if we simplify this, we get a positive number here, 1 over 6 U raised to the negative third power plus C. And then our final answer, remember we need to convert it back into our original variable. That would be 1/6 times 5x squared plus 1 raised to the negative third power plus C. Okay, let's go ahead and check this. So I'm going to differentiate this result to make sure that we've done our computations correctly. So this becomes 1 over 6 times negative 3. Right, so we apply power rule. Okay, so 5x squared plus 1. Negative 3 minus 1, that becomes negative 4, times the derivative of the inside, which is 10x, and plus 0 here. Okay, so what do we get? Negative 3 over 6, that's negative 1/2. Negative 1/2 times 10x, that becomes negative 5x. Here we get 5x squared plus 1 raised to the negative 4th power. That is exactly what we started with. All right, so our final answer is right here. Okay, so what have we done so far? We have power that's a positive integer, power that's a negative integer. Let's do one more example, and here we get power that's a fraction, right? It does not need to be a whole number. All right, so let's see what we got here. The integral of 2x times the square root of 3x squared plus 7. You can think about the square root as this expression raised to the power of 1/2. Okay, so let me go ahead and rewrite it. This is the same as the integral of 2x times 3x squared plus 7 raised to 1/2 dx. Okay, so what is our U substitution? That would be this expression right here. How do I know this? How do I choose this? The derivative of that expression is 6x. I have a constant multiple of the derivative present in my integrand. So that's how I know that that should be my U substitution. Okay, so let's go ahead and select our function g, if you will. So 3x squared plus 7, that's going to be u. And now we differentiate each side. On the left, we get 6x dx. On the right, we get 1 du. Again, I'll look back here in my integral, and I have 2x. So what does it tell me? I need to divide each side by 3. So 2x dx is equal to 1 over 3 du. And now I have all my components set up so that I can rewrite this integral in terms of a new variable. All right, so what is 2x dx? That's just 1/3 du. And here I get u raised to the power of 1/2. Okay. Oh, that's a simple integral. We know how to evaluate it. So what do we do here? Okay, so 1/3 can just be pulled out. It's a constant. So u to the power 1/2 plus 1. So that's 3 over 2, which means we need to multiply by the reciprocal. So that's 2 over 3 and plus c. So we get 2 over 9 u raised to the power 3 over 2 plus c. And then the final answer, remember, we need to write it in terms of x. So that's going to be 2 over 9 times, and what is our substitution? 3x squared plus 7 raised to the power 3 over 2. And then don't forget our constant. So that is our final result. I'm going to go ahead and let you check. Okay, if you were to compute the derivative of this expression. So if we take prime of this answer, we should get 2x times 3x squared plus 7 raised to 1/2. So you can complete the steps of this last step of checking. Okay. All right. So here are your first 3 examples where we apply this method. So as you go through these solutions, please make sure that every step is clear. Okay. The logic of selecting u is important. Okay, look for the expression in the integral so that you have a constant multiple of the derivative also present in the integral. Okay, and then differentiating, determining what your dx is in terms of du. Okay, that's an important step. All right, we'll stop right here. In the next set of videos, I will go over more examples where we use this method to compute integrals with slightly different functions.